Hi guys, in this video we're going to work on the binomial theorem, which is a page 326 through page 328. So we're going to work on the expansion of the power of a binomial. So on page 326 they're having the example for us. So please look at the all the way bottom. So consider the expansion of a plus b to the n power for the first few values of n. So that we have a number of rows, 0, 1, 2, 3, 4. That row is indicating the number of powers, and then you can see the expanded form. So that we are going to pay attention on the coefficients only part, which is 1, starting with the 1, and you are having 1, 1, and 1, 2, 1. So how do we get these results? This result exactly matches the number of in Pascal's triangle. So Pascal's triangle is a triangular array of numbers in which the first and last number of each row is always 1. So I'm going to tell you that how we get these, because starting with the 1 and 1 1 always, and if you are adding those two numbers, it always become the middle. Okay, so I'm starting with the 1 and 1, add those numbers up, which is 3. Add those numbers up, which is 3, so you can get the power of 4 power of 3 this time. So now 1 and 1. So you can just repeat these steps. You're going to get your next one, which is the power of 4. So those numbers are gonna be the coefficient of the expansion of binomials. So please look at the book to page 327. We're going to solve problem 1 together. So what is the expansion of a plus b to the 6th power? Use Pascal's triangle. So let's make the Pascal's triangle together. 1 and 1 1 always. Now what? 1 1 plus 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1. Do you guys see the pattern in here? They are exactly symmetry, right? This is my last one, 1 5 10, and is symmetry to the other part, 10 5 1. So if you are finding the first half part, and you can expect the other. So 1 6 15 20 15 6 and 1. So we are looking for the expansion of power of 6. So I'm good with it. So my last part, I'm going to use these numbers, and then when we're expanding the binomials, you need to know the rule. So I'm going to use the simple example that we're going to predict that how A and B is gonna be look like. All right, can you look at page 326 again? Let's look at the expanded form. So if you have a number of power of 2, what is expanded form there? I had a squared plus a 2ab plus b squared. We already know this format, right? So look at the a and b. Pay attention on the power of a. A, in terms of a, is starting with a 2, which is my number of power, and it's descending, right? 2 and 1, and a disappear. Actually, a to the 0 power is gonna be 1. So when you look at it, your first term right here, that is gonna be descending order, which means starting from your power, it's gonna be going down. Otherwise, your b, your second term, look at it. Do we have any b there? No. So you can expect that your b to the 0 power there, and 1 and 2. So your second power, a second term, b would be ascending order, starting from the 0 to the power. So we're going to apply those rules. So I already got my coefficient of power of 6, which is right here. So we're going to combine those numbers with the terms, which is a and b terms. So I have a plus b to the 6th power, starting with my coefficient 1, and starting with your a, what did I say? It's starting with your power. 6. b to the 0 power. So I'm going to use my a as descending order. So let me change my color into red for a so that you can see the difference. Okay, so a to the 6th power. Now 6, and then we have a to the 5th power. I got b to the 1st power because b should be increased. Now what? Use my third number, 15. My a needs to be what? A to the 4th power. It should be descending. Now I have a b to the 2nd power. B should be increased. Now what is my next? 20. And then my a should be decreased. And my power of b should be increased. And then now what? I have a 15 next. And my a should be decreased. It should be a squared. My b at the same time, that should be increased. Now what? 6, a, and then b to the 5th power. And then what? I have 1 times b to the a to the 0 power. You don't really have to show it, but I just show you this is your first time. A to the 0 power and b to the 6th power. Okay, now I'm going to simplify. So my answer this time, 1 times a to the 6th power times b to the 0 power. Since b to the 0 power is 1, my answer, a to the 6th power, plus 6, a to the 5th power, b, plus 15, a to the 4th power, b squared, plus 20, a cubed, b cubed, plus 15a squared, b to the 4th power, plus 6a b to the 5th power, plus b to the 6th power. That will be the right answer for problem 1. Alright, now I'm going to ask you to complete Guided 1, so please pause this video to do your Guided 1 by yourself, and then we're going to resume the video to check your answer. Okay, so Guided 1. What is the expansion of a plus b to the 8th power? So I have to go back to the Pascal's triangle. Since save our time, please look at the example. Please look at the Pascal's triangle all the way top of the page 327. So which is gonna be my row of 8? You have to look at the all the way bottom one. What is all the way bottom one? 1, 8, 28, 56. It should be too big. 1, 8, 28, 56, 70, 56, 28, 8, and 1. So if you are having the power of 8, you have to go all the way up to your second number is going to be matching as your, power. Okay? So now what do? You just plug in, you are using those numbers with the a and b. As we talked about that your exponent of a begins with your power and is going to be descending to 0. And then, the exponent for b begins with 0 and increase to the power of 8. So I'm going to use that one. And my answer for this one, a plus b to the 8th power would be, starting with my 1 times a to the 8th power plus 8 descending b, 28, a to the 6th power, b squared, plus 56, a to the 5th power, b to the 3rd power, plus 70, a to the 4th power, b to the 4th power, plus 56, a cubed, b to the 5th power, and then 28, a squared, b to the 6th power, plus 8, a b to the 7th power, plus b to the 8th power. That would be the right answer. Alright, so you can see that the binomial theorem on page 327. So the binomial theorem gives a general formula for expanding a binomial. So if you have a at plus b to the nth power, if at this time your n is a positive integer, then your answer would be this: p0 times a to the nth power plus p1 times a to the n minus 1 power times b. So when you look at it, you see that your p0 through n would be the same as a Pascal's triangle numbers. And then a starting with your power of n and decrease to 0. B is starting with 0 and increase to power of n. So now we are going to practice the problem 2 together, which is a little bit more complex compared to your problem 1. Look, what is the expansion of 3x minus 2 to the 5th power? It's the same, but you have to have a skill that you need to write down that one into the a plus b format. What's going to be my a? 3x is going to be my a, but I have to write down as a plus. So your negative 2 minus 2 become the negative 2. And then we're going to expand everything to the 5th power. So when you look at the Pascal's triangle, which one is going to be your numbers for the power of 5, which is 1, 5, 10, 10, 5, 1. Those numbers are going to be my coefficient of the expansion. And then now you are going to apply with your a and b. At this time, your a would be 3x. That's my a. And negative b for your b. So you have to have a mind that you are using 3x for a and then negative 2 for b. Now what? I have 3x minus 2 to 5th power, starting with the 1, times 3x to the 5th power, and negative 2 to the 0 power would be nothing. And then plus 5, 3x to the 4th power, and negative 2 to 1st power, 10, 3x to the 3rd power, negative 2 to the 2nd power, 10, 3x squared, negative 2 to the 3rd power, plus 5, 3x, negative 2 to the 4th power, and my last, negative 2 to the 5th power. So what you need to do next, you're going to simplify all of them. So I will just show you one right here. So if you simplify fully, what did you get it? 3 to the 5th power, 243, x to the 5th power. 3 to the 4th power is 81. 81 times 10 would be 810, but we have a negative there. Your answer should be minus 810 to the 10 times x to the 4th power. Now, 3 to the 3rd power is 27. 2 squared is 4. 27 times 4 times 10, that would be 1080. And they should be positive because negative 2 squared become positive 4. Now what? We're having x to the 3rd power. So you just simplify all the numbers. And then I have a 2 to the negative 2 to the 3rd power, which will become negative 8 times 9 times 10, which is negative 720 x squared. Now, negative 2 to the 4th power would be 16. 16 times 5 times 3, that will be 240 x. And negative 2 to the 5th power minus 32. That will be our answer. Alright, so please work on got it to A and B. Alright, got it to A. So we're expanding 2x minus 3 to the 4th power now. So please look at your Pascal's triangle. What would be our constant this time? 1, 4, 6, 4, 1. Okay? You have to go all the way up to the, second number should be 4. Now, I can rewrite my 2x minus 3 into the 2x plus negative 3 to the 4th power. That will be my A. 2x might be maybe our A, and then -3 is our B. So now what? I got a 2x minus 3 to the 4th power. That would be 1 times 2x to the 4th power. And then 4, 2x to the 3rd power, -3 to the 1st power, plus 6, 2x to the 2nd power, -3 to the 2nd power, plus 4, 2x, and -3 to the 3rd power. Make sure your A would be descending and your B would be ascending. And -1 times -3 to the 4th power. So after that, you have to simplify everything. So this would be 16x to the 4th power, and then minus 96x cubed, because 2 to the 3rd power is 8. 8 times 4 times -3, that would be -96. And then 2 times 2 is 4. 4 times 6 is 24 times 9. That would be 216x squared. Now 216x, you have to subtract it. Let me write down here. Minus 216x, and then -3 to the 4th power, positive 81. That's your answer for A. What about B? Consider the followings. 11 to the 0th power equal 1. 11 to the 1st power is 11. So when you look at these, why do these power of 11 have digits that mirror Pascal's triangle? So at this one, if you're expanding 11 as 10 plus 1, and calculate the powers using Pascal's triangle, and it will be the coefficient. So look, if you are having, let's say, 11 squared, then I can rewrite my expression as a 10 plus 1 squared. That, what did you get? 10 plus 1 times 10 plus 1. 10 times 10 plus 10 times 1. I'm just doing foiling. 1 times 10 plus 1 times 1. And you would have 100 plus 10 plus 10 plus 1, which is 121. So that will be exactly mirror of Pascal's triangle. Okay? Alright, I hope this video helps you, and then let's see you in the next video. Bye.